This is about product of max terms, and here this is m2, m0, m2, m4, m5, that is f of xyz is equal to pi of 0 to 4, 5. So this can be expressed, that means the product symbol pi denotes the ending of max terms. This is about product of max term. Now we are going to discuss about conversion between canonical forms. We have two canonical forms now, product of sum of minterms, product of max terms. We see how to convert product of max terms to sum of minterms and sum of minterms to product of max terms, like that. So this is conversion between canonical forms. See here, to convert from one canonical form to another canonical form, what we have to use? We have to interchange the symbol sigma and pi. We have to interchange the symbol sigma and pi and the list index numbers that were excluded from the original and vice versa. Okay. And first of all, f is equal to f is equal to m3, m5, m6, m7. That is represented as sigma 3567. And the expression for this is x bar yz, x y bar z, x y z bar and x y z. This is the expression. Now, how to convert this into product of max terms? So, what are the remaining terms in this excluded terms? So, what is the first one? Interchange the symbols sigma and pi. Suppose the sigma is converted to pi, first one. And what are the remaining terms? 3, 5, 6, 7. What are the remaining terms? 0 is not there, 1 is not there, 0, 1, 2 is not there, and 4 is not there. So I am going to use those 4, that is pi of 0, 1 to 4. This is pi of 1 to 4. So the expression, so we are representing like this, capital M0 into M1, M2, M4. So here small m3, sum of minterms, and this is product of max terms. M3, okay, M5, M6, M7 plus, and here this product of max terms is M0 into M1 into M2, M4, that is represented as a pi of 0, 1, 2, 4. So another one is, if we have this F complement, now the symbols are M1, this is M0, M0, M1, M2, M4 and sigma 0, 1, 2, 4. This is represented as like this, and we know this one. If it is sigma 0, 1, 2, 4. So the representation is like this, and how to convert this one? The sigma is replaced with pi and 0, 1, 2, 4 are there. So other symbols are, other ones are, there is no 3 here. 5 is here, 5, 6, 7, and I am representing like this. This is M3, M5, M6, M7, pi of 3, 5, 6, 7, and the representation is this one. This is the conversion between canonical forms. Next one is, so I am going to give explain with one example, with another example. So consider this one. Here the expression is f of ABC is equal to the sigma 1, 4, 5, 6. F of ABC is equal to sigma 1, 4, 5, 6. So 1, 4, 5, 6 this is okay, and how to represent f is there. So what is f complement? F complement of ABC is equal to sigma 0 to 3, M0, M2, M3, other than these terms. And the complement of the f dash by De Morgan's theorem is, if we obtain f is equal to M0, M2, M3 bar is equal to M0 bar dot M2 bar dot M3 bar. So M0 bar is M0, M2 bar is equal to M2, and this is M3. That is equal to pi of 0 to 3, where MJ bar is equal to capital MJ. This is the way to convert from one canonical form to another canonical form. And now another one is, here you consider this one. Here we have sum of products. Okay, here convert from one canonical form to another. Interchange the symbols sigma and pi, and list those numbers missing from the original form. So here what are the one terms? One terms are min terms. Okay, one terms, and these are all max terms. So what are one terms here? So here this is one term, this is one, and what are these? 1, 0, 1, 2, 3, 4, 5, 6, 7. 1, 3, 6, 7 as usual. Okay, this is 1, 3, 6, 7, and another one is min terms. The sigma for sum of min terms. What about max terms? So 0 max term, and this is one, and this one. So this is represented as f of x by z is equal to pi of 0, 2, 4, 5. This is the another example. Now, so we discussed about canonical forms. There are two types of canonical forms: sum of min terms and product of max terms. These are also in canonical forms. Standard SOP form and standard POS forms are there. Okay. So now we are going to discuss about standard forms. There are two standard forms. One is sum of products form, and another one is product of sums form. See, here we are having standard sum of products and sum of products. Standard product of sums and product of sums. Standard product of sums means, standard means you should have all letters present in that every term. Okay, right. Now here we are talking about, there are two types of standard forms. One is sum of products form, and another one is, this is sum of products form, and another one is product of sums form. So what is sum of products? Sum of products means, expression is, see, product terms sum. Product term sum, that is sum of products. Okay, product term sum is called sum of products. And the example for this is y bar xy, x bar y bar z. Here there is no z term, there is no xy term, xz term in this. So this is sum of products. And what about product of sums? Product of sums. Okay, so in middle we have multiplication, that is product. That is here product. This is product of sums. This is sum and this is sum. This is called product of sums, and these are called standard forms. So a product of sums is a Boolean expression. A product of sums is a Boolean expression containing r terms. Here n terms and here r terms, called sum terms. Each term may have any number of letters. There is no limit on the letters. That means, if it is a three variable expression, okay, there is no limit in the number of letters. So there is no may have any number of letters. The product denotes ending of these terms. Okay, the product denotes, here this is ending of these terms. This is about product of standard forms. This is about standard forms. Now, so I am going to, this is a two-level implementation. I am going to implement this one. Implement the following SOP function. Okay, implement means we have to design a logic diagram for this. So here we have, how many variables are there? 3 variables. How to represent those variables? We are going to realize one logic circuit for this. See, this f is equal to xz. That means we need one AND gate here. One AND gate. Okay, and this is xz, and another one is, this is y bar z, and this is another AND gate here, and x bar y z. 3 inputs for this, and this is another AND gate, and this is plus symbol. That means we need one OR gate. Here also we need one OR gate. So these are all OR gate. So this is OR gate. This is finally, this is xz, and this is y bar z, and this is x bar yz, and this is equal to xz plus y bar z plus x bar yz. This is the expression. And here this two-level implementation means, here this is called one level, this is one level, and this is another level. So this is called a two-level implementation of the SOP function. Okay. Now next one is implement the following POS function. POS function means, see, product of sums. See here first x plus z. What is x plus z? Here we have x and this is z. And what is the logic? See, logic gate here. This is OR gate. OR gate. Okay. This is one OR gate. And y bar plus y bar z. Y bar z. This is another OR gate. This is another OR gate. And here x bar y z, and this is another OR gate. This is another OR gate. And what we are doing here, this is multiplication and this is another multiplication. This is multiplication and another one is another. This is xz and this is y bar z and this is x bar yz. And here this is AND symbol and this is also AND symbol. We need one AND gate here. We need one AND gate here. This is AND gate. And finally this one is, this is x plus z. This is x plus z and this is y bar plus z and this is x bar plus y plus z, and finally that is equal to x plus z into y bar plus z into x bar plus y plus z. This is the expression, and this is level 1. This is level 1. This is level 1 and this part is level 2. See, this is two-level implementation of this POS function. And next one is here three-level implementation. Till now we discussed about two-level implementation, and this is the diagram for three-level implementation. See, in this diagram we have one level. This is AB and OR gate, and this is second level and this is third level. This is one, second and third level. This is three-level implementation and same expression, and this is three-level implementation and this is two-level implementation. Two-level implementation means AB we have AND gate, CD we have another AND gate, and CE we have another AND gate. For these plus we have OR gate, and this is three-level and two-level implementation. This is three-level implementation and this is two-level implementation. Now, see here what are the observations with this SOP and POS functions? And the observations are, see, canonical forms, that means sum of min terms and product of max terms, or other standard forms. SOP and POS differ in complexity. And this Boolean algebra can be used to manipulate equations into simpler forms. What is the objective of Boolean algebra? We are using this Boolean algebra for simplifying the Boolean functions. Okay, and simpler equations lead to simpler two-level implementation. If we simplify circuits, it leads to simpler circuits. That's where it reduces the speed and it reduces the cost also. This is about these are the observations about SOP and POS. And now we are going to conclude this session. And in this session we discussed about algebraic manipulation. What is algebraic manipulation? What we discussed in that one? See, by applying Boolean algebraic laws, how to simplify the Boolean expressions. Okay, and complement of a function, or how to find complement of a function. Okay, by applying De Morgan's laws, or by applying dual function and dual and complementing the literals, and that is complement of a function. And canonical and standard forms. What is canonical form and what are various forms? Canonical forms means we have two: sum of products, sum of min terms and product of max terms. Standard form means we have two. Those are by using sum of products and product of sums. Now, conversion between canonical forms. We discussed the conversion between canonical forms. That means sum of min terms to product of max terms and product of max terms to sum of min terms. What we have done in that? See, first one, if it is sigma is there, we converted that sigma to see, in place of sigma we have used pi, and in place of see, some numbers will be there now, other than numbers, missing numbers we have included. So that is conversion between canonical forms. For our self-assessment, we have given, I have given one assignment here. Please go through this assignment. This assignment, what is this assignment? This one, simplify the Boolean function, simplify the following Boolean expression to a minimum number of literals. So, minimum number of literals means, see, here ABC plus A bar B plus ABC bar. We have to minimize this one, this equation. We simplify the Boolean expressions to a minimum number of letters. Like this, you have to exercise, you complete this exercise. And another one is implement the Boolean function. We have given one Boolean function. You have to realize, you have to build this by using this expression f is equal to, implement the Boolean function f is equal to xy plus x bar y bar plus y bar z. And with and or inverter gates, you have to realize the logic diagram. By using only or and inverter gates, we have to realize this logic diagram. And by using and inverter gates, and by using with only NAND and inverter gates, next one is NOR and inverter gates, you have to realize the logic diagram. And next one is simplify the Boolean functions T1 and T2 to a minimum number of letters. Here this is T1, this is T1 and this is T2. You know expression, you write expression for T1 first and T2 first, and simplify this Boolean expression. Simplify this Boolean expression like this. And so you work out this also. This is one expression. F is equal to x y bar z. This is one expression we have given. And you have to obtain truth table for f. First you have to obtain truth table for f, and then logic diagram using original Boolean expression. You have to realize the logic diagram. Then use the Boolean algebra, simplify the function to a minimum number of letters. So next you have to write the simplified expression for this expression, and next what you have to do, obtain the truth table of the function from simplified expression and show that it is same as in the part A. So if this truth table is equal to this truth table or not, you have to express, you have to show. And the last one is draw the logic diagram for a simplified expression. So and compare the total number of gates with the diagram with part B. So you do this one. And another one is express the following. Okay, one more exercise assignment is there. Assignment question is there. Express the following function as a sum of midterms and as a product of matched terms. See here, f of ABCD is equal to B bar D plus A bar D plus BD, and express the complement of the function of the following functions in sum of midterms. And this is one express the following function as a sum of midterms and as a product of matched terms. Next one is, another one is express the complement of the following functions in sum of midterms. So complement, you have to find the complement of the function and convert each of the following to the other canonical forms. This is one canonical form, and you convert this sigma to pi and pi to sigma, like this. Thank you for watching.